Oxalic acid is a powerful organic decarboxylic acid that occurs naturally in various plants, including spinach, rhubarb, and beetroot. Yet it is also widely produced synthetically to meet industrial demand. In its pure form, oxalic acid appears as a white crystalline solid that is highly soluble in water, offering impressive acidic and chelating properties that make it exceptionally valuable in numerous industries. Known for its strong ability to bind with metal ions such as calcium and iron, it is frequently used as a rust remover, scale dissolver, and descaling agent, effectively eliminating mineral buildup on metals, equipment, and surfaces. Its unique chelation capability also makes it a preferred compound in water treatment, helping to soften water by binding hardness-causing ions. In the construction and restoration industries, oxalic acid is employed to clean and restore stained wood and marble, effectively reversing discoloration and weathering without causing structural harm. In the textile industry, it serves as a mordant and bleaching agent, enhancing fabric dyeing and brightness. Its reducing properties are further utilized in rare earth metal purification and electroplating, where it plays a vital role in refining, coating, and cleaning metal surfaces. In laboratories, oxalic acid is a staple reagent used in various titrations, precipitation reactions, and as a buffer in analytical chemistry. Its applications extend into pharmaceuticals, where it may act as an intermediate in drug synthesis, or be used to modify the solubility of active compounds. Furthermore, oxalic acid finds use in cleaning formulations and household products, where it removes rust stains from bathtubs, toilets, sinks, and tiles with high effectiveness. Despite its natural origin in many vegetables, the concentrated form must be handled with care, as it is toxic in large doses and can cause irritation upon contact or inhalation. Nonetheless, its environmental footprint is relatively low when used properly, as it breaks down into harmless byproducts like carbon dioxide and water. Oxalic acid's multifunctional nature, ranging from industrial purification and metal finishing to organic synthesis and surface maintenance, solidifies its reputation as one of the most dynamic and essential organic acids in modern chemical applications. Whether in heavy industry or household use, its performance remains consistently high, offering both strength and precision in a broad spectrum of operations.